Bem, pessoal, boa tarde. Então, estamos iniciando o nosso segundo dia aí do nosso encontro, 32º Encontro, Ibero-Americano de Governo Eletrônico e Inclusão Digital. Já é bastante coisa, 32 encontros. Então, essa tarde nós temos um pessoal mais técnico, vão palestrar, então vai ser muito interessante o pessoal do direito ouvir com atenção essa parte mais técnica, né? Então, nós temos hoje convidados da Itália, e depois alguns professores aqui da UFSC, mas tem gente transitando lá pela Itália. Então, rapidamente apresentar, e depois aí eu chamo o nosso primeiro palestrante. Então, nós teremos a palestra do professor Giovanni Sartor e do professor Federico Galli, lá de Bolonha. Então, eles estão com projetos juntos. É um parceiro nosso aqui, recente, de longa data a gente já conhece, evidentemente, o professor Giovanni, mas recentemente nós tivemos a ida de dois membros, aliás, um está lá ainda, né, que é o Thiago, e a Isa fez parte do doutorado dela lá, então, uma aproximação interessante lá com o professor Giovanni lá em Bolonha. Depois, na verdade, nós vamos trocar aqui a sequência. Temos o professor Johnny Fred Rubner, que é professor aqui da casa da UFSC, e ali do Departamento de Automação e Sistemas, e está lá na Itália neste momento. Então, é interessante, dentro desse programa e desse projeto que está caminhando aí com o professor Sartor. Então, muito interessante o professor estar lá, e isso está reunindo aí uma turma boa, né? Então, o professor João vai ser o nosso primeiro palestrante, já passa a palavra a ele, então vai ser uma alegria ouvi-lo. E, finalmente, o professor Jonathan Tisca Carvalho, que eu acabei de conhecer, é professor nosso aqui da UFSC também, ali da... onde é que está o Departamento de Informática e Estatística. Isso. Então, depois eu apresento ele melhor. Então, o professor, vai ser uma alegria também tê-lo aí. Vamos ver se a gente se aproxima também reunindo aí no nosso grupo, todos nós aí trabalhando juntos aí nessa área que envolve inteligência artificial e direito, né? Temas jurídicos. E esse é o tema desse início de tarde. Depois teremos outra mesa, que também continua ao mesmo tema, mas só que agora nós temos uma visão mais técnica. No segundo encontro vai ser um pouco mais jurídico e menos técnico, mas fazendo uma boa interseção entre as duas áreas. Então, fiquem atentos. Os professores, em princípio, vão, se quiserem falar em inglês, provavelmente vão falar em inglês. Então, o pessoal vai ter que ter um ouvido bom aí, né? Já vão escrevendo as questões, que aí a gente pode ler, escrevam de preferência em inglês, para eu não ficar me enrolando aqui na tradução, ok? Então, eu inicialmente passo a palavra ao professor Johnny. Então, o professor Johnny é doutor em Engenharia Elétrica pela Universidade de São Paulo, e mestre em computação aqui pela Universidade Federal do Rio Grande do Sul. E atualmente é professor do Departamento de Automação e Sistemas. E também agora está visitante na École Nationale Supérieure de Mines et Saint-Étienne. Agora não, né? Isso já foi, né? Então, agora ele está fazendo algo lá em Bolonha. Então, o professor pode até nos dar o contexto dessa sua atividade. Professor Johnny, novamente te agradeço aí pela participação, disposição de estar aí com a gente, ajudando aí na discussão desse tema no nosso encontro ibero-americano. A palavra é sua, meu caro, e obrigado.
Ok, obrigado, Aires, pelo convite e pela oportunidade. Me pediram para falar em inglês, eu vou então passar para a língua inglesa. So thank you very much, Aris and Isabella, for this kind of invitation to talk today. For me, is always a great pleasure to share a bit of my knowledge, what I have learned during my research with you. So I try to make a talk that is not so technical. I try to present a very interesting new topic in the domain of artificial intelligence, that is explainable AI. So my idea today is to very briefly to motivate explainable AI and to give you a very broad idea of this topic and why it's a very important topic for research, for development in the context of artificial intelligence. And so also give you some ideas of how artificial intelligence systems can explain themselves for the users. So I will focus specifically in the domain of machine learning. So the way of machine learning systems explain themselves. And of course, given the time we have, this will be superficial introduction, so I will not go into technical details here. So it's just some initial presentation to open a discussion. I also would like to say that I am not an English native speaker, so my English is not the best one. So if it was not clear, please ask me later, and I will try to improve the explanation. So let's start asking you to make an imagination exercise with me that we may consider someone that is in a very important moment of his life. He is thinking about changing completely his career. And this guy has a lot of doubts about how to proceed and how to continue his career, if he changes it or not. And to help him in this big decision, he tries some alternatives or some counselors to help him. And the first one, just supposing and imagining that he goes to this kind of future-telling person that is able to foresee the future and help people to make decisions. And then our guy goes to that woman and tell his case, like, I have just finished the university course. I now have a good position in a big enterprise. I have a very good salary, but I'm a bit not so happy. And I'm considering to change my life and to move to another thing. What do you think? What do you what advice did you give me? Can you give me for my decision? And the woman said simply that she does the things with the cards, select some cards, turn them, see the cards, read the cards, and say to that guy, you should change your career. Oops. And the guy, okay, he's not so convinced by that advice. And then he goes to another kind of counselor. And he goes to this new ChatGPT 5.0 next generation and ask to tell the same story to ChatGPT and ask for some advice. And ChatGPT also said, yes, you should change your career. It was a big surprise. The guy is still not so happy, and then he tries a third alternative. So he goes to some system that was trained with a lot of cases of people in similar situations and professional people that help them to make decisions. And all this data was used to teach a machine learning technique here in this picture, artificial neural network, to help people to take this kind of decision. And then again, our guy gives some data as the input for the system, like his age and his salary, I don't know, some data. And this system gives some output that again is, yes, you should change your career. And then this guy, even there's 3 advices that are the same. He's not very convinced yet about taking the decision. Then he wants to go further and ask, for instance, each of the systems or these counselors, why did you advise me such advice that I have to change my career? And when he asked for that future, that woman about the reasons, she answered that the reasons for her advice is because of that card that was turned. And that card means that there is an open future and very nice future in the future, very nice perspective in the future of this guy. And that's the reason she gives that specific advice. Okay. Then the guy also asked ChatGPT about why ChatGPT has advised him to change. And then maybe ChatGPT can give as an answer for the question, something like that. Because given the words you gave me about your history or about your case, the word that is more probably to come next is yes. And because of this probability, I'm saying yes to you. Okay. And then he goes to the neural networks and again asks, why did you advise me to change my career? And the neural network said as the answer, because you give me some X property that I multiply by some weight W, and I sum them all, put them in a sigmoid function that gives me the value of 0.9 that is greater than 0.6. And so, yes, you have to change your career. And here in this very imaginary scenario, we can see that we have some problem. Even though all these counselors shared the same opinion about what to advise, they fail in explaining the reasons about that advice. So the guy there, the poor guy, trying to get some help in his decision. Now, of course, he can, for instance, just trust in those advices and move on. But what this guy wants was not just an advice, but advice with some reasons to change. And that kind of explanation or that kind of details about the advice was not given by any of these 3 systems that he went to get advice. So in some sense, when that person puts the why question, the answers, or what we call now the explanations for the result, are not very, very good. In some cases, the explanation is probably incomprehensible for him. For instance, the explanation using probability, he is not is not something that he's able to understand. And also the explanation that comes from the neural network guys is not something that helps him to decide. It's not comprehensible for him. So there is no reason, it's not comprehensible. So that kind of explanation is very, very complicated for him. And that is the kind of answers we have in several kinds of artificial intelligence systems. So the users of those systems must simply trust on them, blindly in some cases, blindly trust on them. But I would also like to highlight that in some applications, or AI applications, or applications in general, to understand the system is not enough. Even if I fully understand how a neural network works, what is a sigmoidal function, how is the process of learning in neural networks, even if I understand very well that technique, it's not enough for a good explanation, because understanding the mechanism doesn't give me any clue about the reasons, the real reasons of some result in terms of causality, for instance, or other things. And in some cases, it's even not necessary to understand how that technique works to be happy with the explanation. In some cases, we don't need to understand the system. In our daily life, we are very used to systems or tools that we do not understand, and that's not really a problem. Just to give an example, the electronic fuel injection of every car nowadays may use neural networks, but we don't care. We even don't ask why in that system. So it's not a matter of understanding the system. The issue is about the quality of the explanation in terms of reasons and to be comprehensible by the user. So what makes some explanation from a system to be good? The first aspect for a good explanation is that it's focused on the user. The user that is asking why is usually a person, and that person has a background. He knows some technologies, he knows some words, he has a background, and the explanation should be aligned with that background. So in the same language, I can say the explanation should be in the same language, in the same level that the user are used to. Another aspect of a good explanation is that it should be convincing. I mean, the explanation doesn't need to be the best explanation or the right explanation or the true. It's not the case. I would say that one important aspect of that explanation is that it convinces the users. Again, the user. So the user is very important. And of course, that explanation should be in a comprehensible language in terms that the user can understand. And of course, there are very different kinds of users. Some of them are more exigent than others. Some users are very general. Explanations is enough. For others, you have to give more details and so on. So the explanation system should be very concerned about the user that is there and how much details should be given and so on, in what language and so on. So a good explanation is something that we can idealize, but is indeed very difficult to produce by machines in the case of artificial intelligence. Even in human interaction, explanations are difficult to produce. So now I will move from a more concrete example of how an artificial intelligence system can explain itself. So it's a very simple case of a machine learning technique called associative rules. So in this case, we have, for instance, several examples that are given that are collected during years about diseases and hospital cases and so on. And then based on these several examples, some machine learning technique can produce some rules, some associative rules like the one that here, that is if some patient has fever and high blood pressure, then that patient should go to the hospital. And this rule that is produced by this technique is a kind of generalization from all the examples given to that system. So in some sense, from several cases, from several examples, this general rule are produced in this kind of this technique of machine learning. And when we use this kind of machine learning, where the output are rules, and notice that these rules it has a format like if then, and they are written using words like fever, blood, hospital, that have some meaning for people related that knows that are using this system. So it's quite easy for this kind of system to produce explanations. So for instance, if there is a patient that comes and the system recommends to go to the hospital, and the user asks why you are recommending me to go to the hospital, the explanation could be simply because you are going to the hospital because you have a fever and high blood pressure, and because that rule was used, and then the explanation is quite simple, but very useful, very readable, and very convincing, because it uses words that the user understand, and is quite reasonable as an argument. We can even go further and ask for the system, can you give more information about that decision, that advice? And then the system can say something like, I have 5,000 cases like yours or like this, and in 99% of them, the decision is to go to the hospital as a recommendation from doctors. So it's, again, a very solid explanation and reasons to follow the recommendation of the system. So this kind of systems are called self-explainable, because the way the knowledge is represented, like if-then rules using words, can be very useful to explain and to give a good reason for the output of the system in a good vocabulary. So we have an explanation that are using meaningful symbols and the relation. I say that this system has a very nice background model. It was built using a model that helps the explanation. And that background model, in this case, is symbolic AI, where the idea is that we can represent the knowledge or the generalizations using symbols and the relations, the causality relation between those symbols. And of course, it's very useful for explanation. And this background model also has some strong assumptions that decisions like those one about going or not to the hospital can be taken based on symbolic reason, as we suppose people do. And it also assumes that how that cases that are used to produce that rules that are collected in the past, that cases or that situations remains today. So we can still use those decisions given by the doctors in the past. And that learning is a kind of generalization. So a lot of assumptions in that background model used to produce associative rules. But in machine learning, you have also other techniques. So a very common one is neural network model. In that case, we take the same examples, put in the machine learning tool, and it produces an artificial neural network. That, in some cases, is more effective than the associative rules. The accuracy and the performance is usually better. But then, if we ask that neural network to explain the output, we have almost nothing, because there is no the background model here that is based on neurons and how they are connected, and that background model doesn't help the system to explain itself. So it's quite difficult for a neural network that doesn't handle symbols. This is not manipulating symbolic knowledge or reasons and relations, causalities. There is nothing like that. There is just neurons and connections between them, very like the brain of someone. So for these systems, it's quite difficult to explain. So it could be even worse if the output of the machine learning technique is what we call a black box, something that we don't know how it works inside. Could be a neural network, but could be a very deep learning, could be a convolutional network, could be even decision tree, something. We don't know what is inside this black box, but it's something that is able to produce results. And how this black box can explain itself. Just to give you some approaches, one possible approach is that you keep that idea of machine learning producing that black box, but we are also using the other machine learning techniques that produce the rules. We do the two approaches. And if you have some case where the black box produce some decision and the rules produce the same decision, then we can use the rules to explain the black box. So in that case, it's easy, but the problem arises when the decision of the black box is not the same as the rules. So in that case, we cannot use the rules to explain the black box. Another approach could be to try to produce rules from the black box. It could initially seems very complex or impossible, but it's not a very difficult case, because you can just observe the black box thousands, millions of times, collecting examples of the behavior of this black box, and then use usual machine learning techniques to produce rules based on that behavior of the black box. So again, it could be possible to produce a system where the background is symbolic for that black box. But again, we cannot be sure that this symbolic model is producing the same decisions as the black box. Could be quite similar, but it's not 100% equal. So again, it could be very difficult to explain the black box. So to produce explanations for systems where the background model is based on, we don't know, like here, black box, could be a very challenging problem for artificial intelligent systems. So in general, just to summarize a bit this idea of background models, in AI we have two main background models. The symbolic AI that focus on the idea of a mind and reasoning on top of symbols. So the claim of this approach of AI say that intelligence comes from the manipulation of symbols, the idea of a mind. So we have very nice, very good and solid inspiration for this approach in logic, for instance. The second most common approach or background model for AI is the connectionist AI that claims that intelligence comes from neurons and how they are connected. I would say that is more inspired on the brain and neuroscience, and is very effective and produces very nice results. All the good results we are experiencing nowadays from AI comes from this background model. However, connectionist AI suffers from explain itself. It's like ChatGPT, neural networks, and the fortune teller in the beginning of my presentation. The explanations are not very good. It's very difficult to produce, while symbolic AI is quite strong. However, usually connectionist AI has a very nice performance and very nice results nowadays, far better than symbolic AI, especially in terms of learning tasks. So one possible approach that everybody is trying to investigate is to mix these two background models. I mean, try to develop systems using symbolic approach and also neurologic approach. The main problem is this approach is that we don't have a strong background on other science for that. Symbolic AI can be founded on the logic, for instance. Connectionist AI can be founded in neuroscience, but neurosymbolic approach, we don't have in the science good models of that hybrid approach for humans. So we don't know how humans work, how hybrid humans could work, and then this approach is very difficult to be followed by artificial systems. So just wrap up, I guess my time is running. So explanation is a fundamental aspect of some applications, and here in the domain of law, of course, we can make decisions based on reasons, on strong foundations, on I don't know, some other laws or some principles. So to take decisions in the domain of law, we need reasons and strong reasons. We don't need just some output of a neural network. So explanations is very important in the case of law in particular. And some AI tools are very good for explaining themselves, others are not. And ideally, the conceptual model used by the explanation technique and the user conceptual model should be aligned. And I am just starting to research on that domain of explainable AI, and we can see several challenges there. And for instance, some approaches could be to develop new techniques on AI that are able not only to learn the examples and generalize them, but also that are able to learn to explain. I mean, the process of learning considers also to capture ideas, things that can be later used to explain the system. So to change new machine learning techniques that are focused on explainability. And neurosymbolic AI, of course, is one approach. I just want to mention briefly that and acknowledge that this work was started with Thiago Del Ponto, a PhD of mine, that in the context of his work, we started to investigate this aspect of explainable AI in the neurosymbolic approach. And also some agencies that are financing this research, CNPq and CAPES mainly, but several others that are supporting this research. So thank you very much. And sorry if I didn't stay on the time.
Explanation, huh? When? WhatsApp? I have some questions to you here, but in the WhatsApp, I need to open it. Quem é Isa? Thiago? Eu posso fazer.
So I'll be here in the webcam. So thank you very much for your presentation, Jome. It's a pleasure. It's a great pleasure to know you virtually. I'm Professor Jonathan from INI, and I've been working with artificial intelligence in the last years, not with explainable AI, but artificial intelligence in general and data science. And my question is about something very new, very recent that OpenAI has published about using the new version of ChatGPT, the GPT-4 model, for explaining the decisions of GPT-2, the most simple model of them. So they are training the GPT-4 for explaining this more simple model of they had. So my question is, what do you think about it? Do you think it could be a good idea? If you have some thoughts about it, because in theory, it would be connectionist AI explaining connectionist AI in a very different way.
Yeah, good question. Good. Thank you for that. As I said, I am just starting on that domain, and my knowledge is quite limited on that. But my initial impression is that this kind of a system explaining another system could be a very nice approach. In my slides, I try to illustrate that using associative rules to explain neural networks. So in the case of ChatGPT, that are language models, so we have a language model that explains another language model. And the advantages of that is that language model is meaningful. It's using words that users can understand. And it's all focused on that. So I'm not aware of this new work you mentioned, but I do say that could be very interesting approach. And of course, for us in the domain of artificial intelligence, ChatGPT is bringing a lot of new ideas, is blowing up a lot of new things. And so it's very, very interesting to see how all this will progress. We made an experience here using ChatGPT to explain some programs, computer programs. So we gave some programs to ChatGPT and asked the ChatGPT to explain it to us, and the result is quite good. It's quite good. So could be interesting to investigate.
Okay.
But anyway, the explanation is another language model. It is not explaining how ChatGPT works internally. So that's not, of course, is not useful.
Okay, Johnny, another question.
Hello, Professor. Thank you so much for your presentation. My question is that do you think it's worth to put much effort to combine the symbolic AI and the connected AI to find a strong method? Do you think it's possible to combine these two, actually, symbolic AI and also connection AI?
Sorry, the sound is not very good. Combining what?
Okay. Combining symbolic AI and also...
I get combining connectionist AI and symbolic AI. Yeah.
Sorry,
that's the approach Tiago is investigating his PhD thesis. So I think it's a good approach to investigate, and Tiago is doing that. But it's very difficult. In the initial thought we have, it's okay, just combine the two. But the problem is that we do not know how to combine symbols and neurons, and it's even true for humans. There is no good explanation for how our mind that thinks connects to the neurons and to our bodies. It's the body-mind problem that is known by philosophy since I don't know how long. So it's a very huge problem that, of course, we cannot solve it in engineering. And so maybe you can do some workarounds to handle that. So in the beginning, it looks like a very nice approach, and it should be investigated. But I don't know that we will have nice results. For that, of course, we have to do a lot of research to know that.
Okay. Joey, another one. What is necessary for an explanation to be really convincing? What are the main challenges for the construction of explanation from neural network and other black boxes?
Yeah. To be convinced by an explanation is very, very subjective. So it's not something, I guess, that initially, at least, that it's very difficult to measure that aspect of how some explanation convinces someone. So it depends a lot of the user, of the guy that is receiving the explanation. For some of them, it's a very general ideas of could be enough. Others would like to receive more details, and so it's very user dependent and also domain dependent. It depends of the application and a lot of things. So although the word is I use that word, that an explanation should convince the user. From a practical perspective, from a science perspective, if you want to evaluate how good is an explanation, maybe we should go more on using other means to evaluate the explanation. Okay, you can always ask the user if he's happy or not with the explanation and measure like that. But on the other side, there are kinds of explanations that in some domains are quite acceptable. For instance, in the domain of law and the work in the thesis of Tiago, there are some kind of patterns or argumentation schemes that are usually used by the guys or for people doing law. And if you give your explanation following those schemes or those patterns, people are convinced by them because they are used to that kind of argument or the explanation. So in some domains, we can try to identify this kind of patterns of explanations that are more convincing than others. But it's a very good question, and for sure it deserves a lot of research too. Again.
Do you think, John, que ChatGPT do very good explanations?
I didn't use it very much to answer you. I am not so impressed by ChatGPT anyway, but because he's just read a lot of text and is able to compute the probability of the next word. So the form I show is just like that. So there is nothing really impressive on that, except the scale, because he read more text than any human in the universe. But since he's handling text and using a lot of texts that are available in the internet, and those texts contains explanations, I would say that ChatGPT can produce nice explanations. I don't doubt that. But I'm just I didn't study a lot about ChatGPT and his capability. What I can comment on that is that ChatGPT is very good in producing general explanations and general text. So for instance, if the advice is quite general, I guess the explanation could be quite good. But ChatGPT, I would say that is not very good for specific cases. If you are handling a case that is uncommon, the explanation will not be good, I guess. But just some guesses here from my side.
Okay, very good. Thank you, Johnny. Your lecture is very interesting. The explanation about knowledge now is very important. So I think you, Thiago, and the group now is very interested in this question. So I think we have many work to do. Thank you. And
thank you for the opportunity.
We continue, but after the other's lecture, you could intervene, huh? Okay?
Okay.
What is this? Ok. Não tem mais questões, não, né? Ok. Então, so, I invite Professor Sartor and where is that? Here. Professor Giovanni Sartor and Professor Federico Galli to do their lecture. Very happy to see you again, Professor Giovanni. Thank you very much for accepting the invitation. So, I read now a curriculum about you and Professor Federico, and I pass the here. Professor Giovanni is Dr. PhD in the European University Institute, Florence, professor of, tá em português e inglês aqui. Estou me enrolando aqui. Professor de informática da Universidade de Bolonha, in the Unity of CIFID, AI for Law and Governance, no Centro de Investigação Alma-I da Universidade de Bolonha. E o professor Federico é PhD em Law, Science and Technology, University of Bologna, postdoctoral Research Fellow, CIFID, Alma, AI University of Bologna, postdoctoral Research Fellow, University of Urbino. Thank you very much for accepting the invitation, Professor Giovanni and Professor Federico. The word is with you.
Okay, thank you very much. I hope you can hear me well.
Very well, very well.
Okay, great. So I would like to thank the organizers of the conference, and in particular my old friend, Professor Iris, which I met a long time ago in Florianopolis. A special thank also to Isabella Sabo and Tiago Del Ponte, with whom I could collaborate during, and I still collaborate during the stay in Bologna. I will make some comments first on my experience. I have a lot of experience on using symbolic models to deal with legal reasoning and argumentation, and there is still a big role for such model for providing explanations, as we learned also from the previous presentation, but also we can combine the symbolic representation of rules and principles and the use of non-symbolic models to connect the rules to the facts of specific cases. My colleague Henry Praken and Claudius Bex are doing excellent work in this direction. Also Kevin Ashley. I'm not an expert really in machine learning, but I have been working recently on using also machine learning to deal with the law, and in particular to deal with judicial cases. And before giving the floor to Federica, I will say something about my experience in this domain. I have been working in a project. It's called the Project Claudette, where we built a system to automatically detect unlawful clauses and unfair clauses in contracts. And this is a system based on supervised learning. There were expert lawyers who identified unlawful clauses in a training set of 150 contracts, and then the system on this base learned to distinguish unlawful and lawful clauses with a good accuracy, apparently. So this system mimics the behavior of lawyers built on the training set, and in a way it predicts also the behavior of adjudicators to the extent, obviously, that the attitudes of the experts tagging the training set reflect what can be expected from the judges. So this system was successful. Now we are applying the same approach also to privacy policies and to insurance contracts. Then we moved into a project that Federico is going to present, which is the Project Adele, where we tried basically to adopt a similar approach based on supervised learning to a large set of a larger scope of judicial material in the domain of trademarks and patents, and in the domain of tax law. And we found some difficulties. We had some interesting results, but also some difficulties, in particular the difficulty of building training sets that would enable us to have meaningful outcomes. And then now, to finish, I am involved in a new project where also on the basis of the what we learned during Adele, we try to support, in this case, tax judges. And this project is called Prodigit, and Tiago is involved in that. And we also make use of the large language models that were mentioned for the purpose of extracting principles, summaries and principles out of cases, and of linking cases to decisions and arguments. But unfortunately, I will not be able to speak of this project because this is ongoing work. I hope for the next conference, if you will be so kind to invite me again. So I stop here, and what we are going to do in the rest of our presentation is to present the results of the Adele project, and then I will make some general comments on the meaning of predictions in judicial cases and the feasibility and the advantages of using, in particular, machine learning tools for predictive purposes. Now I would like to give the floor to Federico, and then I will come back again.
Okay, thanks a lot, Giovanni. Can you see the slides? I bet yes, you can see them. Yeah, okay, perfect. Good afternoon, distinguished professor and fellow attendees. I'm very happy to be here with you, although remotely, and join Giovanni in this presentation. So, as Giovanni said, this presentation represents the results of a joint effort and reflection on the potential of legal prediction with artificial intelligence. In particular, as Giovanni anticipated, we share our experience on the project, which is about to finish and has been ongoing in the past 2 years, is called Adele. So one of the objectives of this project was to test the possibility of using AI to predict outcome of legal cases. So the title of our presentation today is Approaches to Legal Prediction, the case of the Adele project. The presentation will be split into 2 parts. So I will present our work in the Adele project, and then I will again pass the floor to Giovanni, who will provide some general consideration on the perspective of using the AI for judicial prediction. So this is the first part. Yes. So the context of our research is provided by the field of legal analytics. As many of you may know, this is a field which uses data analysis, machine learning, and different AI techniques and apply them to legal data in order to extract knowledge, patterns, and makes also prediction about the future. So it deals with a large volume of legal information, such as cases, courts cases, statutes, regulations, and legal documents. The purpose is to gain a deeper understanding of the legal system and improve decision making. So there is a huge interest in this field, as you may know, among judges, lawyers, lawmakers, law students, and other legal practitioners. So on this premise, we have been coordinating this Adele project. Adele stands for Analytics for Decisions of Legal Cases, which uses AI techniques, different AI techniques, and especially natural language processing techniques for the analysis of judicial cases, as Giovanni said, in 2 legal fields, namely the trademark and patent legal area and the VAT, so the value-added tax in the tax law domain. The project was funded by the European Justice Program and involved the participation, as you can see here, from the on the right of the slide, several partners, not limited to academic, but also a firm in Bulgarian company who provides legal informatics services and software. We represent the component of the University of Bologna and the European University Institute. So the main objective of the daily project have been first to develop methods to extract knowledge and predict the outcome of decisions, and second, based on these methods, to try to build a kind of prototype or pilot tool, we would say, to support legal research and decision making in the judiciary. So this is a tool that is namely specifically designed for judges for their use in decision making. Different functionalities can be found in the pilot tool, such as a database of cases with smart search tools, such as automatically extracted keywords and summaries, an ontology of the domains, of the two domains, which can be used to navigate through case law. And there is a module containing citations, network analysis between cases and legislation. So you can navigate through the links between the case law contained in the database and the citation to the legislation. There is a module connected to the possibility of extracting arguments from cases. So you would give the system a decision, and the system is able, to a certain extent, to extract arguments from the motivation given by the court in that specific decision. And then one of these modules is based on the objective of predicting outcomes of cases. So this is the module I would like to present to you now. This module was implemented, as I said, using, as Giovanni also anticipated, as using the automated analysis of the text, so natural language processing, to attempt to predict the outcome of cases. As you may know, this approach includes several techniques that try to extract correlation between the text of a decision, in particular the lexical and syntactic and semantic content of a decision, and the outcome. Several works have been carried out using this approach. You may be familiar with the work by Letras of 2016 on the decision of the European Court of Human Rights, where the prediction of the outcome consists of a binary classification task where the input is the textual content of a case and the output is the binary outcome of the judgment. So whether or not the European Court of Human Rights found that a specific provision of the European Convention on Human Rights was breached or not. Then similar methods have been used, for example, by Medvedeva and Italia in 2020 in works that targeted, again, the case law of the European Court of Human Rights. But other works have been carried out using this approach. So in our work, we started from the assumption that there exists a correlation between the way the facts and the procedural aspects of a case are described in court cases and the outcome. So our expectation is that if our AI model is able to recognize the statistical property between legally relevant part of a case and its outcome, then we can expect that once properly trained, the machine will be able to predict the expected outcome of a new case, a case that was not contained in the training dataset. For the reason, we focused our work on the structure of decision, trying to isolate those parts that contain legally significant content that may affect the outcome of a case. For example, we examined the types of request of the parties, the claim, so the statement that are that may support the request or attack the request of the counterparty in the proceeding, and also the arguments that are put forward by the parties, to which are the factor and the legal reasons that provide grounding for the claim. And we also examine the relationship between these parts. So, for example, we found whether a claim, an argument is supporting a certain claim, or perhaps attacking a counterclaim. So try to identify these different relationships within the decision. As Giovanni said, we used a supervised learning approach, which means that legally relevant information within the decision have been manually annotated by legal experts to include machine readable tags in the text. So then using NLP and different embeddings techniques, the data, the text is transformed into a mathematical representation and used to train and test a machine learning classifier. So this is basically the method that we, the pipeline that we developed. The corpus we created contained about 250 decisions. So we ran experiments both in the VAT case law and in the trademark and patent cases. Each decision may contain several requests from the parties, and the table here in the slide shows the distribution of the request according to the degree and the outcome. This is, I think, the numbers that refers to the VAT dataset. The decision were annotated by legal experts trained in reading and analyzing legal decision. This was a really time-consuming task, as you know, annotation can be. We developed also to facilitate this task. We developed a customized annotation tool. This is called SendTag. So it allowed us to highlight through different kind of functionalities the portion of text that the annotator wanted to be tagged with a specific tag. We relied on complex annotation guidelines, which attempted to restrict the discretion of annotators to use tags in the text. And to assess their reliability, we calculated the level of agreement between annotators through this kind of confusion matrices that you see in the slide below. The task was modeled as a binary classification. So for each given questions and possibly claims and arguments supporting the questions, the system should be able to predict the potential outcome given to that specific request. Also, to check our model, we also performed the experiment to assess the extent to which other parts of the decision may be informative for the task of predicting the outcome. So we also ran some experiments, including in the input data, also the justification, so the motivation provided by the court and the decision. We adopted two embeddings techniques, the TF-EDF and the SBERT, and we experimented with 5 common machine learning classifiers. So if you see from the table, the task of determining the decision outcome based only on the claims. So this is the first column of results. So with the claims and the arguments, reaches a maximum score of 0.68 with linear support SVC and SPERT. So the result is not so high, but it is in the average of other projects, other works that have been carried out using similar methods. This is how the model was integrated into the pilot tool. The pilot tool is open in the web, so if you you want, you can freely navigate and test these. Of course, this is a functionality provided in the Italian language, but still, if you are interested, you can surf yourself within the at this link, the link that you see in the slide. So basically, here the functionality works that the user is asked to type or copy paste the request of a party and possibly other information that may be legally relevant for the judge to decide the request. And after filling in the form and click on the button, on the blue button, so predict, the system would return in a message box, as illustrated in the slide, a score and a possible outcome. So this is how the outcome prediction model is implemented in the Adele platform. Let me conclude before I pass the floor again to Giovanni with some limitation and problems that we have encountered in this project, which will also be elaborated in the next slide by Giovanni. So first of all, some limitations. We noticed that there was a high variance in the legal cases that were included in the dataset. So we noticed that, for example, various aspects related to the VAT cases were addressed in the decisions, and that introduced noise in the dataset. So the prediction was not very good because the cases that were provided to the machine learning models were very different one to each other. And so the model was not able to provide a specific prediction. Another issue is related to the fact that we use the requests, claims, and arguments as included in the decision. So, of course, this may introduce a bias in the system because, as you may know, so the judges, when writing decisions, may filter the content provided by the parties and also change some aspects related to the argumentation. And this, of course, is not fully representative of the arguments and the facts that may be introduced by the parties in the proceeding. So this limitation could be removed to a certain extent by considering the information contained in the documents provided by the parties, but these documents are not openly accessible, at least in Italy, and there is some data protection issues that need to be taken into account. So another crucial limitation is explanation, which is a hot topic also related to in the field of judicial prediction, because our model is not currently able to provide an explanation of the prediction. So you can definitely agree that providing a kind of score of the possible outcome is not enough for a legal professional, a judge, to use this prediction in the decision, in his or her decision making. But I will leave these issues to Giovanni. I think he will elaborate more on this. Then, just to conclude, also I think it's interesting to underline the fact that this kind of project also have some technical barriers which deal with the problem of access to legal database, which in Italy is quite limited. And even when it is available, the process of pre-processing documents can take a long time. So this underlines the need to for a strong movement towards full digitization of legal information and also accessibility to legal information. But I think I can stop here and pass the floor to Giovanni for the second part of the presentation. If you agree, Giovanni, I can move the slides for you.
Okay, thank you very much, Federico. There is not much time left, so I'm going to be quick in my presentation. Let me see whether I can share the slide. Okay, I can share the screen. Maybe I don't know how to share the screen. So let me just try. Presenta, condividi schermo. Okay. Okay, I hope you can see my. Select the table to share entire screen. Okay, share. Okay, I hope it works now. Let me go to my presentation, which is here. So as I said, when we moved into this project, we had the experience of the Claudette project. Let me also remind you that there is an application of Claudette that is going to be done also in Brazil, Claudinha, and I hope that is going to be successful. But when moving into a much larger domain, we had to face quite some problems. And I think that these problems are connected to the idea of legal prediction, in particular when legal prediction is understood as a prediction of the outcome of cases, of the future decision of judges. And as a matter of fact, this is a very difficult task on which, as far as I know, there are very few results that are really helpful to lawyers unless we focus on very small domain. We have a lot of prediction going on now in the legal domain, but in these cases the term prediction is understood in the broad sense in which it is used in AI to mean any case in which you extract, you infer information from existing data. I will not comment on these aspects such as prediction concerning the behavior of case. Much controversial issues concerning, for instance, the prediction of recidivism. But we can speak of prediction also with regard to identifying relevant cases connected to the cases that the judge is considering, relevant fragments, citations, annotation, abstracts, summaries, keywords, factors. Even in the kind of cases in which it is said that the system is predicting the outcome of cases, usually very often what is done, and also what we did, I must say, is rather the classification of existing cases, in the sense that a fragment of a case is used to infer the outcome of the case itself. And there is a typology of prediction on which I will not go into that. I would like also to distinguish two ways in which prediction can be used in the legal domain. In some cases, as in what we did, we move directly from some textual elements into a prediction of the outcome. So the prediction is basically is based on the linguistic similarity somehow between the text that we are examining and past text where a certain outcome was obtained. So it's based on linguistic similarities, and there is a lot that can be done on linguistic similarities, as proved by the so successful large language models now being used. In other cases, instead, from the text, some features or factors are extracted, and then the reasoning of the machine is not based directly on the linguistic structure, but on the features that are extracted by from the case. This approach was not used, I would say, in the Adele project, where we focused on machine learning, which had been so successful in the Claudette system, but dealing with larger set of cases, we found difficulties. The other approach we are also experimenting, but it's in the new project that I was mentioning. Seems to me that machine learning have difficulties. Machine learning systems have difficulties in predicting the outcome of controversial cases. When based on linguistic similarity, the predictive capacity is quite low. In our case, it was lower than 70%. And this is due also to the fact that this system are really unable to understand the human significance of the cases, and to model legal discretion. But still, we must, when considering this kind of system, we must also consider the pragmatics of their use. What are we going to do with that? With the prediction that in a certain 0.7, there is a 0.7 likelihood that the new case will go in a certain direction. And then you must consider then lawyers may use this as a forecast. It is more difficult to say what the judge is going to do of the prediction. For the judge is not going to predict what he or she himself or herself are going to do. For the judge, the prediction is a suggestion based on what the system predicts that other judges, the average judge, will do in that particular case. And then there is the problem of the explanation that we have considered. So I think when analyzing a predictive system, we have to wonder what is the purpose? Why are we using this system? What do we want to predict? Do we want to predict what decision is more likely to be adopted, the kind of decision by the average judge? Do we want to determine what decision is legally correct? The two things are correlated if we assume the judges are normally right, but not necessarily they are identical. And then another problem that is very important, I think, when considering prediction of legal cases, in particular when the prediction is going to be used by judges, is that there is no ground truth, I think, in the legal domain. In other cases, for instance, in medical diagnosis, a ground truth exists. So if the system makes a diagnosis, then we may discover whether the patient has or not the kind of pathology that was diagnosed. But in the case of a legal prediction, how are we going to compare what are we going to compare the prediction of the system with the actual decision of the judge, which may be right or wrong, with the decision of the appeal judge, maybe. But there is not a kind of ground truth through which we may refer. And then another issue that we may wonder, let us assume that we have a system that is able to provide predictions of the outcome of cases with some accuracy. Then, especially when in the judiciary there are some different opinions on the matter, we may expect that the system, if it is built on a sound NLP and statistical basis, is going to predict the outcome of the average judge. And then we may wonder, okay, if all judges were using the same system and were following its suggestion, they would converge. There would be less noise, less dispersion in the judicial decision, but this does not ensure that the average really is where ideally the correct legal decision, if there is any, should be. So there are some problems in using prediction of outcomes as a tool for the judging themselves. But still, we may consider that a way to test the alternative outcomes, an indication. Ideally, we should have a system that just not tells us what is the most likely outcome, the average outcome, but that indicates alternative solution, possibly suggesting which one is more likely. And then there is the problem of an explanation. Why should the judge follow a percentage without having an explanation of why this kind of judgment should be endorsed? The task of the judge is to ascertain the facts of the case and to provide justification for this decision, which is crucial in the legal domain. So, what shall we do with prediction in the legal domain? My idea is that the prediction of outcomes, in particular with regard to judges, as a tool for judges, is a bit overappreciated. There is too much interest for it. Probably we should focus currently at the state of the art on the use of predictive systems in a broad sense for a set of auxiliary tasks which judges need. From selective retrieval based on the similarity of documents, from the construction of graphs of concepts automatically extracted from the document, for the generation of explanation, the extraction of principles out of cases. So my view is that at least with regard to the activity of the judges, these kind of tasks will be more useful. I think I can skip over this kind of slides and come to an end to my presentation. I think that there are vast opportunities for AI to support legal decision making. As I said, we can identify a set of possible uses of prediction of the importance of cases, of their expected duration. This is also something which is very important for organizing the workflow in the courts. Outcome prediction, I think, has been over evaluated, over prioritized over other tasks. But I think that especially when using opaque models, anyway, we have to see, the technological development in the AI domain is very quick, and maybe my so cautious, to some extent negative considerations are going to be overcome by new amazing developments, as we have just recently seen in the case of the various versions of GPT. So I stop here and thank you very much for your attention, and I look forward to your questions.
Thank you, Professor. There are very limitations. Very good, your project, Adele project, yeah? But I see there are many limitations and barriers. Do you think symbolic project is better than this one of machine learning?
Maybe I can say something about that. I would say
if
that
I can say something, that is my opinion, then I see what Federico says. But my opinion would be that we need to go. It depends in various. The problem with the symbolic approach is what is usually called the knowledge representation bottleneck. So if you have humans representing rules, this is a very time-consuming task. The outcome is uncertain. It is very difficult to capture fuzzy concepts. So there are a lot of problems. I think that in many domains there can be an integration between symbolic approaches and machine learning. Maybe the easiest integration would be to model principles and rules using a symbolic approach. And then use machine learning to match the rules to the facts of the case. But there are certain things in which I think that the machine learning is good, is fine. So when we have, as I said, the example of our Claudette system, where we used NLP and various machine learning models to detect unlawful clauses on the basis of their linguistic similarities with unlawful clauses in previous documents, I think is an example of what you can do with a machine learning model. We also have now an attempt where we try to combine the machine learning approach to the use of linguistic rules expressed in a rule language. We have a
We have problem. Yeah. Federico.
Yeah, maybe okay. Maybe I can add to what Giovanni said. Also, I was pointing out in the presentation that we encountered lots of technical and also I would say human-related barriers because our selected approach was based on supervised learning, as I said, and this required huge work done by humans in annotating legal cases to provide the machine the examples upon which to learn. So I think that a kind of serious reflection should be made upon the I would say the efforts that are needed to build artificial intelligence. To a certain extent, I would say that when we say artificial intelligence, very few aspects of a system are actually artificial. I think there is lots of human intelligence behind a machine learning system, at least based on supervised learning, which requires really a lot of effort also in trying to what we saw during the Adele project is also that we really needed a strict cooperation between among lawyers and computer science to define a really solid annotation framework that could provide a useful knowledge base for the system to learn. So I think that another aspect that we should reflect on is to develop to go in the direction of developing artificial intelligence to help human experts, for example, to annotate documents. So in that domain, I think that the use, for example, of semi-supervised learning techniques, where the annotation is done also by machine learning system, would be really helpful to handle this kind of project where really a huge effort is needed. I would say that it is also quite not satisfactory, especially we saw that in the Adele project, where we needed to annotate the structure of a decision, which is something that can be very alienating, I would say. I can say that because I was one of the annotators, so I really have experience on that. But then I agree, of course, with what Giovanni said, because also symbolic approaches in this kind of project are really time-consuming and quite complex if applied in the legal domain.
Okay. Mm-hmm. We have another question. Giovanni? Não, ele não está aí. Você vai ser do plural? Você.
Okay.
Okay.
Yes. Yeah, sorry, I lost the connection, but now I am back. It should work now. Sorry.
Hello, Professor Giovanni and Federico. First of all, special thanks for your participation. I am very happy to see you both again. And my question is about methodology, and I agree with Federico. Besides the good results about the predictions, there is a lot of legal professionals, legal researchers effort in preparing the data. So my question is, according to your experience, which methodology is better? Extracting and information from legal texts and transforming it in structured data, or making the annotation, the process annotations in the legal texts. So, in your opinion, according to your experience, which methodology is more appropriate?
Thank you, Isa, for your question. I actually didn't work on a different methodology. So this is a step that we wanted to do in the next phases of the ADELE project, to try to identify factors which are legally meaningful in the text of the decision. But I think that approach would be equally time-consuming. But I would say that maybe from a perspective of a lawyer, it would be more challenging, to a certain extent also more interesting to follow that approach, because even though it could be, time-consuming and long, it is a kind of different of bluntly annotating the structure of decision, which is, as I said, it could be really alienating to a certain extent. So I would say that it would be more, at least this is my perspective. It would be more challenging for a lawyer to adopt that kind of approach.
If I can add something, I think that now we have new tools that can be used for that, and I think that in particular the language models are useful for extracting automatically keyword or concepts from documents, and also for associating automatically existing conceptual structures to documents. So I think that we should having manual annotations from the raw document, having somebody doing manual annotation for large and different data sets is something that should be limited in the future if we want to have a kind of working approach, and we should develop automated tools for supporting the work of annotators. This is, I think, the challenge that we need to address. There are some domains where human annotation is fine. As I said, for instance, we had the positive experience in the Claudette project, but in that case, we have a very limited focus. And it was also, let me say, interesting for the doctrinal, from the legal study. So in this case, there was an interest in the annotators for the content of the documents, and also the domain was quite restricted. In the broader domain, as when we engaged in the Adele project, annotation was a long and difficult project, and I wonder whether it can scale up. Unless there is a useful AI support, human annotation in regard to a data set which has multiple contents is, I think, a very difficult goal to achieve. And then the law changes, so new annotations are needed. I don't know. So it's similar. So we have, as we had with the knowledge representation bottleneck, we have also have the knowledge annotation bottleneck, which is as serious as the first one, probably, I would say.
Very good. Yeah. Unfortunately, we don't have more time, Professor Giovanni and Federico.
Okay.
Thank you very much.
Thanks a lot.
Thanks a lot. It was a pleasure to be with you.
Okay. Very good. We have another lecture, and in the end, we could speak a little more. Agora, então, convido o professor Jonathan Tisca Carvalho para fazer sua palestra. Doutor em computação pela Universidade Plymouth, da Inglaterra, né? Mestre em modelagem computacional e engenharia da computação pela Universidade Federal do Rio Grande do Sul, professor adjunto do Departamento de Informática e Estatística aqui na Universidade Federal. Aqui está colaborando também como pesquisador associado ao Instituto de Ciências Cognitivas e suas tecnologias em Roma. Mais um italiano aí. Professor, obrigado pela sua participação.
Obrigado. Vou ajustar a câmera só se eu ficar aqui em cima.
Aqui em cima tá legal. Pega bem.
Pega bem?
Uhum.
Bom, então, good afternoon, everyone here in Brazil. Good evening in Italy, for my colleagues in Italy. It's a great pleasure to be here. Thank you very much for the invitation. I have to say that this topic, this particular field of application is something new to me. I've been working with artificial intelligence, machine learning, and data science in the last years, but this domain of application is something very recent, actually. We are starting a project in with the Prosector's, Public Prosector's office here in the state of Santa Catarina, and one of the lines of investigation is about fraud and corruption detection in the public sector. So it was great to prepare actually this talk, because I've learned a lot and I've kind of did my job, my initial job in the project. So thank you also for that. Very good. So I will try to be quick, because we don't have so much time. But I prepared 4 parts in this talk. The first one, a very brief introduction with definitions and context. The second part, I will talk a little bit about the opportunities, why I think it's a good idea, and we in the project think it's a good idea to use artificial intelligence for supporting this fraud and corruption detection in the public sector. And then I will talk a bit about the challenges and pitfalls in doing that. So I had to start with the definitions. Maybe for you from the law field, it's very clear what fraud and corruption is, but since my background is in computer science, I'm a computer engineer, I had to start from the beginning. And then I went and brought this definition. Fraud, it's any deliberate act for the purpose of obtaining an unlawful gain. And corruption is the misuse of power to obtain an unlawful advantage. They are similar, but we can see that corruption involves this position in which the person doing it has some power. It could be, yes, you can pass. It could be in the public sector or in the private sector. My focus today and in the project is, yes, you can go on. is in the public sector. It's hard to see, but it's the public sector. I have to say that fraud is a whole universe. We have lots of research in fraud detection for different areas, application areas as insurance, benefits from social benefits from the government, and many others, phishing, scams, and stuff. But our focus is specifically the public sector. So something that is very important and everyone knows is that fraud and corruption in the public sector, and we have unfortunately lots of that here in Brazil, but not only in Brazil, it's a worldwide problem. It's spread worldwide. And a very old one also. It brings lots of harmful effects, and this is not just a perception of it. There are lots of researches that quantify how much this problem affects, for example, investments reduction, damage productivity of a country and economic growth, diminishes the quality of procurement services, and mainly exacerbates income inequality and poverty, which of course generates lots of other problems. So it's something very important to tackle. The question is why AI would help, and why now? As we know, AI has been around since the 50s. We had many decades of promises and stuff. So why bringing this kind of technology back and trying to detect fraud and corruption? But so on. Just to be fair, actually, this kind of application is not something very new. We had some examples of systems using AI to detect fraud in the 90s, but it was very, not many systems were trying to do that, and not so promising results were achieved. As we will see now, it's a much better time for doing that. So we know that from the pandemics, we have an acceleration in the digital services. So since we had to stay home, we had to develop many services that were required personality or physicality, and we moved to the digital world. So this accelerated a lot the production of digital data, which were already something happening, right? Also the advance of information technology over the last decades, which it keeps progressing, and also big data technologies and techniques, and mainly artificial intelligence recent breakthrough, which are happen, let's say so, mainly due to many factors, but three of them that are very important are, now we have lots of data, so we are really in the big data era. We have lots of computing power, and it's easy to access them with the cloud providers and stuff. And we have also easy to use AI libraries and machine learning libraries. Everyone can use these libraries now, not only the computer scientists and stuff. So I found this very nice and recent work, which is from University of Bologna, maybe the Italian colleagues know, Fernando Dilla. And it's from March of this year, and they propose and they map actually the benefits and limitations of AI-based and corruption technology, and they also map which are the technologies in Brazil using AI for detecting corruption and fraud. These are, it's not an exhaustive list, but it's a quite decent one, a quite significant one. And they saw that there are 23 systems by governmental agencies, one associated to IBM, which is from Federal Police in Brazil, and 7 created by civil society. All the systems are deployed, are currently deployed. They are not being researched or developed. They are actually in use right now. Just to bring also another perspective, this is another not so new work survey that shows that there are 64 AI projects in 47 courts in Brazil, and this is not only corruption and fraud detection, it's more wide. I brought this number because it is related to your event, so I think it's interesting, but it's not so new. So probably there are much more works in this area. So something that I think is very interesting are those data in which Fernando Villa brings this recent survey, which is actually from the Court of Accounts, in the Federal Court of Accounts in Brazil, that shows that 72% of 263 governmental agencies consulted don't use any kind of AI system for their job, while another survey from a private company that advises other companies show that only 14% of private sector corporations don't use data analytics for detecting some kind of fraud or corruption. So this shows this big gap between the private sector and the public sector, and how much research we can do and how many opportunities we have in the public sector. So why we have these opportunities? Why is it a good idea? As I said, digital transformation, everything is going digital right now, so many different devices and systems generating digital data. So we are, the data is growing bigger and bigger over the years. We have also a variety of laws in Brazil that are anti-corruption and that enforces the government to publish data, to create databases, as the archives law, the access to information law, the open data also portal, and many others. So we have lots of structured data, and we have also lots of unstructured data, mainly because of social networks, social media. So we have images, audios, texts, videos, mobility data created by GPS devices, all the smartphones that we have. So we have all these different sources of data that maybe we could integrate and use for this kind of task. And of course, there is something very important. Since we have this ever-growing amount of data, we have lots of opportunities. But consider that for someone that is trying to hide, it's like the haystack and the needle problem, right? It's hard to find a needle in a haystack. So the more we have data, the easier it is, if we don't have the proper tools for analyzing the data, to hide in this huge amount of data. So what can help us? Big data analytics and data science, if we discover the stepping stones on how developing this kind of technology, we can find these hidden patterns. You can go there. There was a thief there. So some opportunities are related to technologies, new technologies and techniques that were not, they didn't exist many decades ago or some decades ago. For example, data lakes in which we can store, process, access a huge amount of data, different kinds, heterogeneous kinds of data, like structured data and unstructured data. We have high-performance computing, which is much better now. We have faster computers, we have cheaper computers, we have easier access to this kind of service. And we have also new techniques, as for example, the most famous now is deep learning, which can be used for many things, from data extraction to analytics itself. So we have many challenges. What challenges we have to solve? Yeah, I can go on. So we have many challenges related to computer science, to data science. I've listed a bunch of them. There are many others. We start in which data we have to collect and integrate to, for example, to detect frauds and corruption. Since fraud and corruption is they are umbrella terms, so we have many different, even in the public sector, we have many different kinds of frauds and corruptions going on. So we have to study very well the problem. We have to have people that know very well the problem. And from our first talks to the public prosecutor's office, it's a very manual problem. It's a very manual approach. They trust a lot on their experience, on their intuition, and this is something that it's a challenge by itself. We have to extract and model that knowledge and use it to help us to understand which data we have to collect and which sources we have to integrate. How to integrate and store heterogeneous data is already by itself also a problem, and many of them, which infrastructure and that data models are more indicated, how to reprocess the data. You can go on. It's kind of, I've just listed them in somehow with some kind of logic, linear logic. So after doing that, how to use this data together for the analysis using artificial intelligence and machine learning, which methods should we use or adapt or create. So we can see that there are many subfields of computer science, of statistics. We have to involve people from different areas, and it's definitely a research problem. So we won't have some kind of company right now that are going to sell some very good solution, perfect solution for detecting this. So we have to involve lots of people. Yes, I put there also how to deploy, monitor, and update these systems. First of all, how to validate that the methods developed really do what they're supposed to do. We have to be sure before deploying them. And after that, how to deploy, how to integrate that on the routine, the work routine of the auditors, the prosecutors, and so on, and also the ways of monitoring and updating these models. Because since it involves someone trying to obtain some kind of advantage, obtain some kind of gain, they probably are going to adapt as well together with the model. So we put a very good model, a very good detection system. People trying to cheat these systems are going to adapt themselves. So the process have to take that into account. Also, explainability is a very important issue here, because if we have models that are biased or that are not very accurate, we could even make the problems worse. And also, right now, a challenge is the fact that the LGPD, the GDPR version of Brazilian GDPR version here, is in its infancy. Not all the institutions are prepared, have already defined the roles. And then there are lots of insecurities also about the boundaries of privacy and data collection and use. And also, since Brazil is not like very well adapted to the law, there are current barriers for collaborating with international institutions. Europe, for example, they didn't put Brazil in a list of possible collaborators yet. I have some projects with people in Rome that they cannot share the data because of the situation. So this is a potential challenge that we have to overcome. The fact that it's a very interdisciplinary research is a challenge by itself, because we have to involve lots of researchers from different areas and sub-areas. So we have computer science with many of its subfields, statistics, economics, law, social science, and probably many others, because there are so many dimensions and aspects involved. And putting all these people together and put them to talk is not an easy task. Even if they want, the vocabulary is different, the way of doing research is different, so lots of efforts are required for putting that together, let's say so. And also we need the involvement of multiple institutions, academic and research institutions, courts of accounts, public prosecutor's office, federal police, federal and local governments, and also civil society. This is very important, because otherwise we are going to create like just systems for control and for only enforcing some institutions' power, but we are not involving people. So again, having all these institutions in the same initiative or project or, I don't know, coalition against fraud and corruption is not easy. So we have to talk a lot, lots of diplomacy and so on and so forth. So in the end, the pitfalls, so we have very important things to be aware of. I've listed some of them in the top level, but I'm sure we have many others. As I said to you, this is something that we are starting right now. I'm not an expert on this field. I probably will be in 4 years or 5 years after we already did the project. But we already know that for example, the performance of the AI systems or the false promises of the AI systems can be a barrier, because people that now are willing to use are motivated for using this. Maybe they will not be like that if we don't achieve what these systems are the promises that these systems are doing. This is a very interesting point. We have to be very careful of AI not creating more fraud and corruption, because if we create systems that are not used well, it could make the problem worse instead of helping. And also many ethical concerns as bias, privacy, surveillance, creating a system that is just surveilling the citizens, so creating this kind of, or achieving this kind of dystopical world, as in the 1984 George Orwell's book. Also, opaque decision making, and this is why explainability is important. So each of these points are like an entire research field that, or the research direction that we have to worry about and to think about. So it's not definitely an easy thing. For all these things, transparency is very important. So this is something that the work of Fernando Villa that I've listed there shows very well. They really interviewed governmental institutions, and they saw that there is no pattern for providing data or not. Some institutions are saying, no, I cannot provide this because this is sensitive data. Other institutions at the same level are providing that. Some of them are saying, no, I cannot do this. For example, the federal police, no, I cannot provide you that information because it will damage the investigations that I'm doing. So we have to be very transparent about what can be provided and what cannot be provided. And at the end, there is an extra slide that I will talk very briefly about the CELS project. The project is named after the Titan, the Greek Titan of knowledge, CELS. And it's a very recent, it started last month. It's a research project for support intelligent decision-making in complex domains of the public sector. It's not only about fraud and detection. It actually has 3 lines of investigation. The first one is fraud and detection in the public sector. The second one is about extracting information from not only legal documents, but all documents that they have there, and trying to check consistencies and helping fraud and support detection and fraud and corruption detection and so on. And also the analysis of the occupation of ICUs, intensive care units in Brazil. The project has 8 researchers from different areas, statistics and computer science areas. It's something that we want to expand, so we want to establish more collaborations, and being here is really nice. So we can start talking, and maybe in the near future to start collaborating. We are talking to other governmental institutions as the Court of Accounts of the state, the Santa Catarina state, TCE, and also with the federal police, and we are going to try to establish this big network of collaborations with many different institutions, because everyone is trying to tackle this problem. They have also the duty of avoiding this problem. They have different data sources, they have different knowledge, they have different perspectives from the problem. So if we manage to really create this kind of network, we will have a big advantage on really creating systems, AI systems that are really useful and that go outside the lab instead of only publishing papers and stuff. That's it. Thank you.
Thank you, Jonathan. Some questions? About this project, the techniques that you think you use?
Yes,
ML,
yes, we definitely, since we have 8 researchers from different areas, we probably are going to investigate the use of many different techniques. So that goes from going from symbolic AI. We have some researchers, a researcher on that area, passing through machine learning, lots of machine learning, of course, and also statistical methods. So we have 2 researchers from statistics, and there are many methods. I think the most historical methods for detecting fraud and corruption are statistical. So we are going to test all them. It's really a research project, so we are not promising to develop a tool. Of course, if we find some kind of interesting method that can be used in a tool, that can be useful for the public prosecutor's office, the Ministério Público, we are going to develop it. But the project is about understanding what are the best methods, how should we plug the things together, which data source we should use, developing a huge platform for data that can combine heterogeneous data, images, audios, videos, documents, structured database and stuff. So we are going to test all these methods.
Time?
5 years.
5 years.
5 years. It's a quite long project, and it's just the beginning. Actually, beginning now. Yes, that's small. Yes.
Thank you for the nice presentation and for the definition, because I got in the law department, and the definition makes me feel better. My question about the high performance computing. I like to know how high performance computing can help the machine learning to be in a real application now. If you make it more elaborate.
Mm-hmm. Yeah, it's a good question. As I have shown, the opportunities that we have right now, and actually the big advances that we had in the last years in machine learning, deep learning stuff, is related to the huge amount of data that we can use now. The techniques that are used for training these models are old. Like the first neural model is from the 40s. The techniques used for training, for creating the neural networks are from the 70s or 80s. So they are not quite new techniques. Of course, there were improvements, but most of the impact was now we can train huge neural networks. So, for example, ChatGPT has 175 billion parameters, and this is huge. And actually, GPT-4, it's probably around 1 trillion parameters. So it's huge. You need to have huge computing power for being able to deal with a huge amount of data, pre-processing this data, and for training these models. So this is how HPC comes into the scene.
Vem cá, ou fala bem alto. Tem que falar no microfone. Aqui.
Hi, Jonathan, and congratulations for your presentation. What's the main challenge for the use of IA in the public sector? And what do you think about the need for regulation?
Good questions. So the first one, I think, is more related to making the institutions, the different institutions, to work together. So, for example, we have this project because the public prosecutor's office here in Ministério Público, Santa Catarina, came to us and said, okay, we want to use AI for helping us. And this is good because here at the university, we are researching these things, we are developing new methods, but we always work with public data sets or things that allow us to do research. So we are developing methods in machine learning, computer science, HPC, big data, and stuff. So for us, it's very good to do that, but we cannot do that alone. Ministério Público cannot do that alone. Federal Police cannot do that alone. So we really have to gather all these institutions together, talk, exchange ideas, and develop systems, test systems, and stuff. And this is surprisingly hard. We have been talking for, I think, 1 year before we arrived to this point of starting the project. We hope to have more collaborations with other researchers here at UFSC, other universities, other institutions in the world, other governmental institutions as well, of course. And about the regulation of artificial intelligence, yes, I think it's very important to do that quick. Because as we saw, ChatGPT was already something very interesting. I disagree a little bit of Jomi, because the model is not exactly only predicting the next word. Of course, this is part of how the model is trained, but then there are other training processes that embed the model with other capacities. There is this method called reinforcement learning with human feedback. So the humans are saying there, okay, this is a good answer, this is not a good answer, this is a good answer. And this somehow makes the model more aware of what's a good answer and what's not a good answer. So it's not only predicting the next word. Even if it was, in nature we have lots of complex systems that are produced with simple rules. So even if you have just a simple rule producing something very interesting, which is ChatGPT, GPT-4, which are not perfect, of course they are not, but they are progressing so fast that they are definitely, and they are already changing the way the world is, and they are changing even more. So many areas like education, medicine, law, and they are be profoundly changed by these tools. So regulation is super important, otherwise we are going to go wild. So companies, big companies that are these ones that have the resources for creating this kind of models, they are going to control and do whatever they want, and this is dangerous.
Okay, Jonathan. Thank you. Huh? Thank you. Yeah. Coloca os demais na tela. Final words, because we have no time. Ok, a Jomi está? Os demais não? Ok. Jomi, we have 1 minute. You could say something to end our discussion?
Okay, just to thank you again for the opportunity, and also congratulate the other speakers for the talk. I like them very, very much and learn a lot about. So thank you for the opportunity for organizing this meeting, and also the other speakers. For me, it was a great pleasure to be here, and let's go and do more research and try to collaborate. As Jonathan said, I guess a very important topic here is to build collaborations, and you can get a lot working together. So thank you.
When you return to Brazil?
December.
December. Okay, until there.
Okay.
Okay, thank you very much, Jonathan. Ok, pessoal. Temos uns 5 minutinhos para